Hi, everyone, and welcome to this next installment of Algebra. In this video, I'm going to be talking about rational expressions. Now, I want to talk about a couple of things first before we start getting into any of the problems. Now, in the previous video, we talked about factoring. We talked about factoring polynomials. Rational expressions are a natural next step from that topic because the definition of a rational expression in algebra is an expression of the form polynomial over polynomial, so a fraction of polynomials. The last video talked about polynomials. This one, a fraction where the top and the bottom are both polynomials. Now I'm going to be doing five problems in this video, one of each. So we're going to be problem one will be simplifying, problem two will be multiplying, problem three will be dividing, and then we'll have an addition problem and a subtraction problem. They all have the same first step, factor. Right, again, that's the previous video. I'm not going to be spending a lot of time explaining how to factor in this video. I'm going to just be quickly factoring. And that's the majority of the problem is going to be the factoring. If you still need a refresher on factoring, go to my previous video first, watch my factoring video, and then come back to this one. So polynomial over polynomial. So let's go to problem number one, simplify. Right? Simplify, you've got one fraction. Now, simplifying is conceptually is something you should be familiar with. So if I give you a problem, like, for example, 12 divided by 18, and I say simplify this fraction, you do it the same way as with polynomials. We factor. Factoring is how we simplify. We're looking for a common factor. Now, there's two properties of numbers that are sort of going on in the background here. It's the sort of the justification of why we're allowed to do, why we're allowed to cancel and why things disappear, why we factor. Well, there's two properties of the real numbers. Any number so I'll say any number x times 1 is equal to x, right? Any number times 1 is equal to itself. Hopefully that's ringing some bells and it's familiar. Any number times 1 is equal to itself. And then the second property that also we're using every time we reduce a fraction or simplify a fraction is that any number divided by itself, so I'll say x divided by x, any number divided by itself is equal to 1. 7 divided by 7 is 1. 12 divided by 12 is 1. 14.6 divided by 14.6 is 1. Right? So these two properties are involved in the process every time we're reducing a fraction. Now, go back to 12 over 18. Well, we factor. Each of these numbers is a multiple of 6. 12 is equal to 6 times 2. 18 is equal to 6 times 3. Right? We cancel the 6. Now, I don't want to just say, okay, cancel the 6 because that's what you do. Why? Why are we allowed to cancel the 6? Well, 6 divided by 6 is equal to 1. Right? 6 divided by 6 is equal to 1. So that's 1 times 2/3. And any number times 1 is equal to itself. So that's equal to 2/3. We don't, normally write those extra steps. But this is why we're allowed to cancel. This is how canceling works. Anything divided by any value divided by itself, any expression divided by itself, any number divided by itself is equal to 1. All right, so let's go on to problem 1, simplify. X squared plus 12x plus 36 divided by x squared minus 36. You don't have to think about it. This first step is factor. In every problem, problem 1, problem 2, problem 3, problem 4, problem 5, it's all factor. Factoring is the first step. So for a if the problem is to simplify the rational expression, and then we want to determine which real numbers are not part of the domain of the simplified expression. We'll get to that second. But to simplify, we want to factor. So x squared plus 12x plus 36 is equal to, nope, not x squared, x plus 6 times x plus 6. And then on the bottom of the fraction, x squared minus 36 is equal to x minus 6 times x plus 6. Again, how you get from point A to point B here, how do you factor? That's my previous video. I'm not going to explain factoring in this video, or it would take me an hour to do all 5 problems. So if factoring is an issue, go back to my previous video. Now, any number or any expression over itself is equal to 1, which is why we're allowed to cancel. We have an x plus 6 on the top, x plus 6 on the bottom. So they cancel. And we are left with an x plus 6 on the top and an x minus 6 on the bottom. You can't cancel anything here. You can only cancel when you have factors, multiplication. Nothing is being multiplied on top, nothing's being multiplied on the bottom. We have addition on top, x plus 6. So you have 2 separate terms. You could only you could only cancel these factors when you have 1 term on top, 1 term on the bottom. Okay, so that does it for simplifying. That is how you simplify. You factor the top, you factor the bottom. Maybe we should write these steps out. Factor the top. 2, factor the bottom. And then, not boo, bottom, B-O-T-T-O-M. And then finally, cancel off the common factors. Now for the second part of the problem, right? And then determine which real numbers are not part of the domain of the simplified expression. Right, so now the question is, what could x not be? Right? Remember, x is a variable. In algebra, a variable is a temporary placeholder. A temporary placeholder for a number. So we're going to substitute numbers in for our variables. What numbers are we not allowed to substitute in for x? Well, we have a rule, and that rule is you cannot divide by 0. It's not a rule for algebra, it's a rule for math. It's a rule for real numbers, all real numbers. You cannot divide by 0. Right? The domain is the set of all the numbers that are allowed to plug in for x. So the domain is usually stated as the domain of this expression is all real numbers except something, right? So what is the exception here? The x could be any real number except what? Well, x can't be 6. And the reason x can't be 6 is because if you substitute or evaluate x as the number 6, you plug in a 6 where there's an x. So you take away the x, you put in a 6, you get 6 minus 6, which is 0 on the bottom, which you can't have. So the only number that x cannot be or is not part of the domain would be the number 6. All right, next two problems are very similar. Number 2 is multiplication. Number 3 is division. So multiplication and division. First step, it's the same as number 1, factor. All right, so again, I'm going to go quickly through the factoring. So we get x minus 2. So this is actually 4 factoring problems. This is 4 different factoring problems. Factor the top on the left, bottom on the left, top on the right, bottom on the right. So x minus 2 times x plus 2. And we're factoring 2 fractions. The first fraction on the bottom, that will be x minus 2 times x minus 2. X minus 2 times itself. On the right, on top, we could pull out a common factor, so that's a 2. And we're left with x minus 2. And on the bottom right, well, that doesn't factor. There's nothing to do there. It's too simple already. So that's an x plus 2. All right, so now everything is factored. I'm going to throw parentheses around that x plus 2 on the bottom so everything is nice and separated. All right, we already talked about why we're allowed to do this. If you have the same factor top and bottom on a fraction, we could cancel them. So let me just rewrite the original problem with the factoring so we don't have the crossing out. So x minus 2, x plus 2, x minus 2, second fraction, 2 times x minus 2, and then on the bottom, an x plus 2. So now we can start canceling. We can start canceling things off. So we x minus 2 top and bottom. Then over here, we've got, we could use some color coding here. I'll use green. This x plus 2, I'm going to cancel with this x plus 2. All right, multiplication, everything on the top is multiplied together. Everything on the bottom is multiplied together. So you can think about this as one big fraction. All right, and then let's use, I never use purple. Let's use purple. This x minus 2 is canceling this x minus 2. So in this case, this doesn't always happen like this, but in this case, everything on the top cancels except the number 2. And on the bottom, everything cancels. Now, what do you do? What do you do when everything cancels? Well, you're holding the place with a 1. Don't put a 0 there. Don't say there's nothing on the bottom. It's, see where the 2 is on top right here? This 2 right there, well, we could write a 1 out front, just like there's a 2 there. 2 is equal to 2 over 1. So there's really a 1. There's actually a 1 there. We just don't generally write it. So let me erase that. 2 divided by 1 is equal to 2. And that's our answer. Final answer, once we've simplified, multiplied, we're left with 2. Okay, next one, division. Well, division, if we remember, the way we divide fractions is we multiply. So for example, if I said, what is 1/2 divided by 2/3? What is 1/2 divided by 2/3? Maybe you've seen keep, change, flip. Keep, change, flip. Some people say stay, change, flip. This is how the definition of division for fractions is a conversion to multiplication. So you change division to multiplication. Dividing by a fraction is the same as multiplying by the reciprocal. So that would be equal to 1/2. You keep the first fraction times, you change the symbol. Division becomes multiplication. Keep change, and then flip. The second fraction, instead of 2 over 3, becomes 3 over 2. All right, so that's how we divide fractions numbers. We divide fractions of polynomials the exact same way. So that will be 4x squared plus 10 divided by x minus 3 multiplied by the reciprocal. So flip, stay, keep, change, flip. So we'll get x squared minus 9 divided by 6x squared plus 15. So step 1, convert the division into multiplication. And now it's exactly like number 2. Same problem, just different polynomials, but we have a rational multiplied by another rational expression. So if we look at number 2 and number 3, they're basically the exact same problem, except number 3 has one additional first step where you flip the second fraction, turn it to multiplication. But from here, we do it the exact same way. Factor the top, factor the bottom of each fraction. So I'm going to factor out a 2, and we're left with x squared plus 5. On the bottom, we have an x minus 3 that doesn't factor. Again, I'm going quickly through the factoring portion because that was the previous video. X squared minus 9 becomes x minus 3 times x plus 3. And on the bottom of the fraction on the right, we could factor out a 3. And that'll leave us x squared plus 5. X squared plus 5 again. All right, so now we could start canceling. So got an x squared plus 5 on top, x squared plus 5 on the bottom. They cancel. We got an x minus 3 on top. We got an x minus 3 on the bottom. So we are left with a 2. We are left with an x plus 3 on top, and we're left with a 3 on the bottom. So fraction, multiplication, top times top, bottom times bottom. So we have 2 multiplied by x plus 3 divided by 3. 2 times x plus 3 divided by 3. Another way of writing this, you could also say that's 2/3 times x plus 3. This is just personal preference. Neither one of these is more or less correct than the other one. They both have a x plus 3 in parentheses. They both have a 2. They both have a 3. They both have a fraction bar. So they are basically identical. We call them equivalent. They don't look the same, but they mean exactly the same thing. Okay, I'm going back to the very first slide just for a moment. Okay. Problem 1, problem 2, and problem 3. To simplify or to multiply or divide, the first step is factor, right? Factor each polynomial in each fraction. Factor the top, factor the bottom. You can do that with addition and subtraction, but it's going to add one extra step. So to avoid that, when we're adding or subtracting, we're still going to start the problem off by factoring, but only factor polynomials on the bottom. Only factor polynomials in the denominator. So just factor the polynomials on the bottom. The reason why we're going to combine like terms on top. And combining like terms, we want everything separate. We don't want things multiplied together. So for addition, subtraction, we only factor polynomials in the denominator of the fraction. So again, I'm going to relate this back to whole numbers, right? No polynomials, just whole numbers. Like, how do we add if we have a fraction of two whole numbers? So 2 over 3, whole number over whole number. And we want to add, let's say 5 over 3. Yeah, we could do that. They have a common denominator. They both have a 3 in the denominator. They're both dividing by 3. They're both thirds. 2/3 plus 5/3 equals 7/3. Check. No problem there. But if we were to add 2/3 plus, instead of 5/3, let's say 5 over 4, 5/4. Can't do that. You cannot add 2 over 3 plus 5 over 4 because they have different denominators. So in order to, if we want to add, we first have to get a common denominator. Right, so this is true for fraction. Ooh. This is true for fractions of numbers. This is also true for fractions of polynomials. If you're going to add or subtract fractions, you need a common denominator, which we have in number 4. Just before I write anything else down, if you look at number 4, it's two fractions, we're adding them, and they have the exact same denominator. This and this. They both have an x squared plus 3. But if we look at number 5, denominators are different, right? So now we cannot subtract because we don't have a common denominator. We're going to have to do the same thing we always do with fractions. Get a common denominator first. Right? It doesn't matter if it's plus or minus. That plus could have been a minus. So get a common denominator first. So number 4 is going to be the easy one. Number 4 is going to be the easy one. So this is equal to x squared minus 2x plus x squared plus x, all divided by x squared plus 3x. Now, I didn't factor first. I should have. For this problem, this is a really easy version because you have a common denominator already. We're going to have to factor the bottom. I mean, I could do it in step 2, but I should probably have done it in step 1 just to follow my own instructions. So x squared plus 3x is the same as x times x plus 3. Right, they're the same. Factor out a common x. That's x times x plus 3. So on the bottom, we've got x times x plus 3, right? The bottom is factored, the top is not, because I want to keep the terms on top separate. So now we could collect like terms. On top, we've got an x squared and an x squared. We have a total of 2x squares. Then we've got a minus 2x and a plus x. That is a total of negative 1 x's, so minus x. On the bottom, we've got x times x plus 3. So, step 1, factor the bottom. Step 2, add fractions. And then step 3 is factor the top. Right, slightly different order, same steps, but With multiplication and division, we factor the bottom and factor the top straight away. With addition, subtraction, we're holding off on the top. We still have to factor the top of each fraction, but we're going to hold off until the end. That just, it's the most efficient way, or the least number of steps you could use to get through these problems. So now if we factor the top, each of these two terms have an x in common. So we could factor out an x, and we're left with 2x minus 1. On the bottom, we've got x times x plus 3. And it looks like we have a common factor here. There's an x on top, x on the bottom. Those guys cancel. And we're left with, as our final answer, 2x minus 1. We no longer need the parentheses because there's nothing multiplying, divided by x plus 3. Okay, so this is the sort of the easier case where you're adding two fractions that already have a common denominator. In number 5, let's follow the same steps. Right, factor the bottom. So that's 3x divided by x plus 5 times x minus 2. Right, again, the factoring is what I covered in the last video, so I'm going through it quickly. Minus 2x, and on the bottom here, we've got x plus 3 and an x minus 2. So let me give you an example, just like before, relating this problem back to something a little bit more basic, no variables. So let's say we want to do 2. Let's say we want to do, 5 over 6, 5 over 6 minus 3 over 15. 5 over 6 minus 3 over 15. We're going to have to get a common denominator. And that common denominator, the smallest number that is divisible by 6 and 15, 6 goes into this number, also 15 goes into this number, would be 30. 30 is the LCD. Least common denominator is 30. Now, how do we, if you don't just look at this and say, okay, the smallest number is 30, that's divisible by 6 and divisible by 15. How do we get that mathematically? Well, we factor. 6 equals 2 times 3. 15 equals 2 times 5. So the 6 contains the numbers 2 and 3. The 15 contains the numbers 2 and 5. So it looks like the 6 is missing a 5. The 6 is missing the 5. So the LCD let me erase that. We'll say the at least common denominator should be 2 times 3 times 5. And that's where the 30 is coming from. It's got to contain a 6, which is the 2 and the 3, and it's also got to contain a 15, which is the 3 and the 5. So we multiply the first fraction by 5 over 5. We multiply the second fraction by 3 over 3. We'll do times 5 over 5, that'll give us a 30 on the bottom. Second fraction, we times it by 3 over 3. That'll give us 30 on the bottom. So that's 25 over 30 minus 9 over 30. Now we could subtract. Right, now we could subtract. 25 minus 9 is 16. So we get 16 over 30. We have to then simplify this. 16 is 2 times 8. 30 is 2 times 15. The 2's cancel, and we get a final answer of 8 over 15. Check. Okay, so this is a review of just how to subtract fractions. You get a common denominator. You multiply each fraction by something over itself to get that common denominator. And then you simplify your answer once you subtract. So let's come back to this problem. We have 3x over x plus 5 times x minus 2. And then we're subtracting 2x over a different denominator, x plus 3, x minus 2. The two denominators have to look the same. So the first one is missing an x plus 3. So we multiply the top and bottom by x plus 3. It's the same thing we did over here on the right when we multiplied the first fraction by 5 over 5. You're allowed to multiply by anything over itself because that's equal to 1. The second fraction on the bottom is missing the x plus 5. So we'll multiply x plus 5, top and bottom. All right, we're getting a common denominator. So now, on the bottom, we've got x plus 5, x minus 2, x plus 3. Right, and now we could subtract. Now we could take the first numerator, 3x times x plus 3, and subtract the second one, 2x times x plus 5. Now you may want to pause the video right now and just really absorb how this is the exact same sequence of steps. On the right, when it's only numbers, 5 over 6 minus 3 over 15. And on the left, when we have polynomials. Right, but it's the same process. Figure out what is the least common denominator. Get a common denominator for both fractions. And then add the top or subtract the top, depending on if it's an addition or subtraction problem. This one's subtraction, so we do top minus top. And the bottom is the common denominator. All right, and that's how it's done. That is how it's done. On the bottom, we've got, no, we have some simplifying to do. X plus 5, x minus 2, x plus 3. All right, and on top, let's multiply everything out and collect like terms. So we're going to multiply 3x times x, 3x times 3. We're going to multiply this negative 2x times x, and then this negative 2x times 5. So that'll give us 3x squared, 3x times x. Then 3x times 3 will be plus 9x. Then a minus 2x times x will be a negative 2x squared. And a minus 2x times 5 will be a minus 10x. We could collect like terms now. We've got a 3x and a minus 2x. That will give us x squared. We've got a 9x minus a 10x. That will give us a negative x. All right, we're getting more and more compact, more and more simplified. X plus 5, x minus 2, x plus 3. Now I'm writing every single step, right? So the last thing we could do is we could factor. We could factor the top. We have x squared minus x. They have an x in common, so you could factor out an x. If the bottom is factored, you want to factor the top as well. You want to be consistent. So x times x minus 1. And then on the bottom, I'm really running out of room, but this is it. We've got an x plus 5, an x minus 2, and I'm going to be a little informal here, but everything's multiplied together, and there's still that x plus 3. Everything's got to fit. And so that, which I've squeezed into the corner here, that is our final answer. All right. The overall message in this video, though, is the way we simplify, the way we multiply or divide, the way we add or subtract fractions, just regular fractions of numbers, is the same way we add, subtract, multiply, divide, and simplify rational algebraic expressions. Same math. So let me just partition this off so it doesn't all blur together. And that's it for this video. 5 questions, 5 operations. Hope this was helpful.